Students, today we are going to study projectile motion. So here, as we can see here, there are two conditions for projectile motion. There is horizontal launch and there is a vertical launch. So horizontal launch means the launch or something is thrown that is parallel to the x-axis or to the ground level. It is like this. See, suppose a person is there. Suppose a person is shooting. Like this, and hunter is shooting. Suppose hunter is shooting here, and a bird is sitting here on the cliff like this. So here he is shooting like this. So you can see here, this is parallel. All this bullet is going parallel to the ground level. This is ground level, and these bullets are going parallel, not forming any angle. So you can see it is going parallel. So parallel. So when it is going parallel to the x-axis or ground level, so it is called as horizontal launch. So for that we have to solve few questions to understand how horizontal launch works. So I will take one question here for horizontal launch. So you can see this is the question. A car running at 30 km per hour fell off from the cliff of 47 km height into the sea. Calculate the horizontal distance from the bottom of the cliff to the distance where the car fell into the sea. So first of all we will make a diagram how it will look. So here we will make a cliff. So this is the cliff, and we will make this is the cliff, and we will make sea here, and this is the car which is running here, and it is falling down here. It will fall down like this into the sea during this movie stunt. Okay, so you can see it is falling. So here you can see, here it is going parallel. This is forming parallel to the ground level or sea level. So this is called as horizontal launch. So parallel. So it is horizontal launch. So no angle is formed here. So it is parallel. So we will use the types of formula which is used for parallel launch, and not for the special formula where sine and cos is also taken into consideration. That is for vertical launch, but here sine and cos or theta is not taken into consideration because angle is not formed. So we will take simple equations like the kinematical equations we normally use. V square equals to u square plus 2as, v is equal to u plus at, or s equals to ut plus half at square. So like that we have to use this type of formula for solving these sums. So first of all, we now know that this is parallel launch horizontal to the earth. So horizontal to the earth or plane. So we can use this formula, simple formulas. So first we will write whatever the conditions are given here. So as you can see here, 47 kilometer is the height from the bottom of the sea level to this. So this is 47 kilometer. Means this distance till this distance is 47 kilometers, and car is running at 30 kilometer per hour. 30. This car is running at 30 kilometer per hour. Okay. So that means this car is running and it will move like this and fall into this ocean. Okay, 30 kilometer. So here you can see, as we know that here, always remember, on the x-axis which is parallel, here it is 30 kilometer per hour. The velocity will remain constant. Here also, at this point also it will be 30 kilometer per hour. At this point also it will be 30. At this, whatever is parallel to this ground level, that will be 30 kilometer per hour, because horizontal velocity remains constant. That is the rule. So this is the first thing we know. So we have written here 30 kilometer per hour, and we want to find this distance where it is dropping here from here to here. So this is the distance what is being asked. So this is what we want to find out, distance. So this is what we want to find out. Okay, so now we will see whatever parameters we know, we will write here for x and y. So for x we will write here, and for y we will write here. So for x we know initial velocity. This is the initial velocity, 30 km per hour on the x-axis, not on the y-axis, because on the y-axis car is not moving. Car is moving in this direction, parallel. So it will be x. Okay, it is not moving like this directly, it is not falling, it is running with this speed 30 km per hour and it is falling like this. So this will be x-axis. So x-axis initial velocity is ux equals to 30 km per hour, and here we know this parameter, and we know one more parameter which is not given here. That is the rule, simple rule, that acceleration along the x-axis is always 0. As we know, it is 30 km per hour everywhere at this point, means there is no rate of change of velocity. So rate of change of velocity is acceleration, but here there is no change in the velocity. The velocity is remaining constant at 30 km per hour. So that's why it is a0. Ax means acceleration along the x-axis is 0 because velocity is constant. So we know two parameters for x, and for y we will find out. So you can see here displacement along the y-axis. This is the y-axis, perpendicular. So this is the y-axis, this is the y-axis, this is the y-axis, this is the y-axis. So perpendicular to this. So these all are y-axis. So here you can see the distance from here to here. This is also y-axis. So this is the distance they have given. So this is the distance. So here distance along the y-axis is 47 meters. So we can write displacement or distance along the y-axis is 47 meters. And acceleration, here they have not given here, but always you have to consider acceleration as 9.8 meters per second, acceleration along the y-axis, because it is falling down towards the gravity. So it will be plus 9.8 meters per second, not minus. 9.8 meters per second square. So meters per second square. So always remember this is that. Okay, so if it is falling away from the ground, if it is means you have thrown something and it is moving away from the ground, then it will become minus 9.8 meters again. Okay, but if it is falling towards the earth, towards the gravity, then it is considered always as positive value. So this is the thing. So these parameters we know very well. So we will, and one more thing we are going to, one more parameter is hidden here for y. That is, initial velocity along the y-axis is 0 meters per second. So this is there because you can see the car is moving on the x-axis, okay, with a speed of 30 km per hour. It is not moving. It is not moving downwards. It is moving parallel. So initial velocity it is moving parallel to the ground level, not perpendicular. So there is 0 meters per second. So initial velocity along the y-axis is 0 meter per second. This is one more hidden value that you should remember. Initial velocity along the y-axis is 0 meters per second. So all three parameters we know. Now we will solve here. We can't solve on for x-axis because we don't know three parameters. But for y-axis we know all three parameters, so we can solve for y-axis. So we can use this formula, s equals to ut plus half at square. S equals to ut plus half at square, where a equals to minus g or plus g. According to that, it is falling towards the earth, so it will be plus g, that is plus 9.8 meters per second square acceleration. So we will write all these value according to the equation on the next page. So here we will write for x and we will write for y. So here this is y and this is x here. So now we will write whatever the things we know we have written here. A displacement along the y was 47 meters and acceleration along the is 9.8 meters per second square acceleration along the y-axis, and initial velocity along the y-axis is 0 meters per second. So we will use that formula is equals to ut plus half at square. So for y-axis we are doing, so we will write sy equals to uy t, this is for initial velocity for y, plus half gt square or ayt square, ay and t square. So this is the formula which we will apply. So you can see sy is 47, so we will substitute all these values. 47 we will put here in this, and acceleration we will put here in this, and this 0 meters per second we will put here, and we will solve. So sy means 47 equals to, so you can see here for this it is 0, so the 0 multiplied by 0 means time will also become 0. So 0 into t plus half gt square, half 8 means 9.8 plus 9.8 meters per second, half 9 into 9.8 into t square. So t square is there. So here now it will become 47 equals to 0 t is a 0, so this whole thing will go. So here it will become half into 9.8 into t square. So here t square equals to, this will this will come up 47 into 2, 7 into 2, and 9.8 will come down. So here it will become like this. So here 47 into 2, so t under root it will become, t equals to whole thing will become under root of 47 into 2 divided by 9.8. So 47 2s are 94, 2 7s are 15, 2 4s are 8, plus 1 9, 94 divided by 9.8. So I will do this, solve this on my calculator. So it is coming 9.59 seconds. So the time is coming as 9.59 seconds. Okay, SCC 9.59 seconds is the time we got. So here for x-axis now we got time. So time to fall, we got time as 9.59 seconds. We got time as 9.59 seconds. So for x-axis also it is 9.59, and for y-axis also it is 9.59, because time is same. For falling down from here to here, this distance time is also same. From this distance to this distance, the time is also same, and from here to here also time is also same. So for x and y axis it is same, means for this distance also time is same, and for this distance also time is same. So for x and y the time will remain same only, so we can use the time value in the x-axis also. So this time value what we got we can use here also. So now we will put this time value here, this what is there for x we can use for y also, because time is same, 0.59 seconds. Now we will apply that equation, s equals to ut plus half at square in for x. So we will solve this. So for x we were knowing this, okay, for x all these things we were knowing, so we will write that ux equals to 30 kilometer per hour. So remember, it is 30 kilometer per hour. Okay, so 30 kilometer per hour means now it is in kilometer per hour, so you have to convert it into meters per second. For that, first you have to multiply with 1000 for converting kilometer into meter. So 30 into 1000, then divided by, this is per means divided by, so hours means 60 minute into 60 seconds, 60 into 60. So I will solve this on my calculator. So it is coming to 8.33. So 8.33 meters per second. The answer is 8.33 meters per second. So I will rub this, whatever we have done here, means 8.33 meters per second is the initial velocity along the x-axis. So this is the value which we will use now. This is not needed because we converted it into meters per second. So now we were knowing another parameter. This parameter, acceleration along the x-axis. So acceleration along the x-axis, we just know 0, and time also we know. So it is 0 meters per second square, and time. So time here same value 9.59. We can take it in this side. So time equals to 9.59. So now we will use all this parameter in this formula, s equals to ut plus half at square. So s for this displacement along the x-axis, what we want to find out, equals to u x t plus half a x t square. Okay, so now we will use this formula. So sx means displacement along this x-axis, what we want to find out, equals to uxt. So u is 8.33 into time is 9.59 to 9.59 into half gt axt square. So half into ax is 0, so half into 0 into 9.59 will give 9.59. This whole thing will become 0 because anything multiplied by 0 will become 0. So this whole thing will become 0, so cut it. So we can just multiply this 8.33 into 9.59. I am calculating on my calculator. Let's see what is the answer. Answer is coming. So it is coming 79.88 meters. So 79.88 meters is the displacement along the x-axis, what we need to find out. So this is the displacement along the x-axis. We found out sx. So this we got what they asked, from here to here, how far the distance the car has fallen down from the bottom of the cliff into the sea. So this we got as here the value as 79.88 meters. So this is the answer for this. We will solve another question related to this horizontal launch. Okay, this is that question. So here we can see in the question, a boy pushes his toy car on a table top with a velocity of 6.2 meters per second. The table is having height of 6 meters from the ground. Calculate the horizontal displacement of the car on the ground. So here, as we can see here, suppose this is the table and this is the boy who is playing in the car. He is pushing the car like this, toy car. So here he is pushing. So after some time he will push the car and the car will come to this edge and fall down from here like this onto the ground. So they have asked this, calculate how far the ball lands. So this distance they have asked, from here, from this table is ending here, from here to here, this area. This distance we need to find out. Okay, this is the height of the table. This they have given 5 meter height, so height is 5 meter. So this is 5 meter. So we want to find this, and they have given velocity. So velocity is 6.2 meters per second. 6.2 meters per second. So he is pushing with this much velocity, 6.2 meters per second. So we will find out. Calculate how far away the car lands. So this is the distance. So means it is like this. This is formed like this. There is no angle formed because he is parallel. He is pushing the car parallel to the ground level. There is no angle formed. So here we can solve this question here. So first of all, we will use our formula. What is needed here to solve this question? So as usual, we will use S equals to ut plus half at square. That formula we will use because we know this different type of parameters. So we will use S equals to ut plus half at square. We will use S equals to ut plus half at square because we cannot find distance directly. If we know the distance, then we can, if we know the time, then we can calculate the distance. Speed equals to distance upon time, so distance equals to speed into time. We can use this formula. So first we will find out time. So after getting time, we can calculate the distance easily. So here we will calculate S displacement along the x-axis equals to ut plus half at square. So here you can see displacement. So ut plus half, initial velocity is 0, as we know that it is 0 into t. Along the y-axis it is 0 only, but along the x-axis it is 6.2 meters per second. So along the y-axis, because this initial velocity is for y-axis, so this is initial velocity for y-axis, it is 0, as we know from the previous question also, that initial velocity along the y-axis is 0 when the launch is horizontal. So initial velocity, because it is falling down, it is directly it is pushed parallel to the earth, so it is not forming perpendicular, it is not falling perpendicularly. So that is why initial velocity along the y-axis is taken as 0. So 0 into t, so plus half. So here acceleration due to gravity is 9.8 meters per second. So we have to take the value as positive because it is falling towards the earth or gravity. If something is thrown up, then we can take that as negative because it is moving against the gravity. Then we can take acceleration due to gravity as minus 9.8 meters per second. But here, as it is moving towards the gravity, we will take plus 9.8 meters per second. So 9.8 meters per second into 9.8 meters per second square, 9.8 meters per second square into t square, time square, what we want to find out. So 0 t is a 0, this thing will become 0, plus half, so half, this is 1, so half 9.8, and this displacement we know is 5 meters per 5 meters, so we will write here 5 meters, this is 5 meters. So here into t square, so 5 into 2, this will come up, so 5 into 2 divided by 9.8 equals to t square. So t equals to under root of 5 into 2 upon 9.8. So I will solve on my calculator. So it is coming around under root of 1.01. So under root of 1.01 2 it is coming. So under root of 1.02 is equals to 1. So time is 1 seconds. So now we know this. So now we can use that formula, speed equals to distance upon time. So we will use this formula, speed equals to distance upon time. So now we will substitute the values whatever we know. So speed also we know very well. So speed here they have given here, the value here speed is 6.2 meters per second. So 6.2, 6.2 equals to distance upon time. So time here just now we calculated 1. So 1 into 6.2 will give 6.2 only. So distance equals to 6.2 into 1 equals to 6.2 meters. So this is the distance, this distance what we have calculated, how far from the table it fell. So this is the distance. So we got 6.2 meters is the distance. We will solve another question based on horizontal launch. So here one question we will write down. So here suppose two students are performing some experiment. Students performing some experiment related to gravity. So they are throwing two balls from a height of 5th floor and 7th floor respectively, from the 5th floor and 7th floor. So 5th floor of a tower, floor, and 7th floor, 7th floor of a tower, of a building. So here the 5th floor is located as at 4, we can see the 5th floor is located as at a 6 meters from the ground level, and 7th floor at 9 meters from the ground level, 9 meters. So these two are important, floor is not important. The distance from the ground level, from ground level. So this distance we know, and they are throwing with the same speed, that is 7 meters per second. Speed equals to 7 meters per second. So here now we know this distance and speed. So here we can solve this question. We will draw how it will look. So this is the tower, okay, from the balcony of 5th and 7th floor. So this is 5th floor and this is 7th floor. So 5th floor is at the height of 6 meters from the ground. So this is the ground level. So it is at the 6 meters, and 7th floor is at the, from the ground it is 9 meters. So this distance, 7th floor, from here to here it is 9 meters. So these two things we know. From the balcony they are throwing up two different balls, two different students are there. So horizontally they are launching, no angle is formed, so parallel to the earth, just they are dropping it. So when they are dropping it like this, so it will fall down. This is the ball, first student with the same velocity. So velocity here, here velocity is 7 meters per second. So 7 meters per second, and this boy is also throwing the ball here from the 5th floor with same velocity, 7 meters per second. Meters per second. So you can see here, when this boy is throwing the ball, it will fall like this, and when this boy is throwing the ball, it will fall like this. So these two balls are of the same size, same weight, and with the same speed they have been thrown uh, from the balconies of the building. Okay, at two different height. So we want to calculate when both the ball land on the ground. Calculate the distance. That the difference between the distance means this distance they want to find out. Calculate the difference between the distance on the ground when they fall. How far apart one ball is from the second ball? That is the question. How far apart one ball falls from the second? Falls from the second one. So here we will solve the question. Now we will solve the question using the formula S equals to ut plus half at square. So as we know that we will use for this 6 meter and 9 meter respectively, we will solve separately, and we will find separate time using the same formula, and we will get the time later on, and so we can calculate the distance as we calculated in the previous sum. Speed equals to distance upon time, so distance equal to speed into time. So we can use that formula. So as we know very well here, so we will write down the parameters here. We will use all these values what we have written here. So as we know, in the question we got 6 meter and 7 meter. So first of all we will make like first ball from the 5th floor. So 5th floor, and then even in 7th floor also we will from 7th floor, from 7th floor. So now we will calculate this whatever the things are given. The 5th floor height is just now we have seen here 6 meters and 9 meters. So height means S is here 6 meters, and 7th floor S is 9 meters from the ground level. So this we know. And acceleration due to gravity means A equals to G equals to 9.8 meters per second. It is positive again because it is falling towards the earth. Here also A equals to G equals to 9.8 meters per second square, meters per second square, because we have to take this positive as it is falling towards the earth. So we will now use S equals to ut plus half at square for this. Ut plus half at square. Again initial velocity is 0 here, because along the y-axis it is always, because initial velocity is 0 for horizontal launch. There is no angle formed, so initial velocity we will take at 0. So 0 t is a 0, so this whole thing will become 0 plus half into 9.8 into t square, and displacement means 6 meters. So S we will write here as 6. So here we can write this 2 will come here up So here we can write here 6 into 2 divided by 9.8 equals to t square. So here we can write 12 upon 9.8. So t square equals to 12 upon 9.8. So we will use the calculator to solve. So t square equals to 12 upon 9.8. So 12 upon 9.8 I will solve on the calculator. So here I am getting t square 12 upon 9.8 value I am getting as 1.22. 1.22. So t equals to under root of 1.22. 1.22. Now we know time. So here time equals to under root of 1.22 is coming as 1.1. So 1.1 second is the time. So this is the time we got the value 1.1 seconds. So 1.1 second is the time for the ball that is thrown from the 5th floor with the same velocity. So now we want to calculate this distance. So speed equals to distance upon time. So distance equals to speed into time. So we will use this formula. Distance equals to speed or velocity into time. So distance we can see here. So we got speed, velocity also we know very well. So speed is here 7 meters per second here for this 5th floor, 7 meters per second. So here we will write 7 meters. 7 into time is 1.1. So we will get 7.7 meters. 7 meters for the ball launched from the 5th floor. So 5th. And for 7th floor we will calculate using the same formula. What we have to here we will use using the same formula. So here distance also we will write down here. So velocity of 7 meters per second here. So velocity is same, means speed is same for this also. So speed or velocity. So velocity is here also 7 meters per second. So now we will solve this formula using S equals to ut plus half at square. Ut plus half at square. So as we know very well here, so displacement is here and displacement we know 4 here as we know. So displacement is 9. This is written as 9. So 9 ut initial velocity 0 along the y, as we know very well. Along the y-axis it is always 0. So this whole thing will become 0 plus half, and again we will use at positive because it is falling towards the earth. 0.8 into t square. So we will solve this as usual. So t square equals to 9 into 2 divided by 9.8 into 2 divided by 9.8, 18 divided by 9.8, 2 9 is 18 by 9.8. So another 9 was 18. So approximately I will solve on my calculator. So it will come around 2 because 9 2 is 18. So here it is coming 1.84. T square equals to 1.84. So t equals to under root of 1.84. 1.84. So under root of 1.84. So time equals to under root of 1.84. Let me calculate here. So it is coming 1.37 seconds. 1.37 seconds. So we got time here as 1.37 seconds for the ball that is being thrown from the 7th floor. So now I will calculate the distance for this one from the 7th floor. So distance equals to speed into time, or velocity into time. So distance we want to calculate. Velocity is same here as usual for 5th floor, and for 7th floor it is same because they are performing experiment and throwing at the same velocity. So we will write here 7, velocity or speed as 7 meters per second, into time we got as 1.37. So let's calculate here. 7 sevens are 49, and we will calculate here on my calculator, and it is coming 9.59. Distance is coming here 9.59 meters. So here two difference. Now we want to find out how far apart the ball has fallen. So here as we know, 9.59 and 7.7. So 9.59 and 7.7. So means this distance, the ball that is fallen here, this one, from here to here, just now we calculated here, for the 5th floor was 7.7 meters, and from here to this ball, so this distance from here to here we got as 9.59. So the difference between both this will give the how far apart, because 9.59, this whole distance minus this will give that. So here as we know here very well, so here this ball has fallen here, and from the 5th floor ball has fallen here, and 7th floor ball has fallen here, and this is the tower. So now this was the distance here for the 5th floor ball. This is the 5th floor ball, and this is the 7th floor ball. So now just now we calculate the distance. This 5th floor ball from the bottom of this tower, the distance is 7.7 meters, this distance, and this distance for this ball from here to here, it is coming 9.59. just now we calculated 0.59. So we want to find out this distance. This is the distance which we want to find out. So this minus this will give that distance. So 9.59 minus 7.7 will give you how far apart they have fallen. So far apart, or distance between the two balls. Far apart or distance between the two balls equals to 9.59 minus 7.7. So let's calculate. So it is coming 1.89 meters on my calculator. So this is how we solve this type of questions. So now we have done the sums based on horizontal launch, and we have also understood what is horizontal launch. Let's go through and have a quick recap on horizontal launch. We read an example that a person is shooting using his gun towards the bird, but the range of the gun is very small, so the bullet will fall after some times here. So that is in this way it will fall like this. So here it is going parallel, till here it is going parallel to the ground, then afterward it is forming a curve. So this is horizontal launch. Whenever parallel, it is that whatever objects or things are thrown or shooted, so it will fall down onto the ground. After running to some few parallel direction, then it will fall down. So this type of launch is called as horizontal launch. We will take another example for horizontal launch. Like suppose a table is there. and a boy is rolling a car, push car, small toy car. So he will roll the car on the table. So after some time this car will come here. It will run parallel to the ground level, and then afterwards it will fall down like this. So this is horizontal launch. Here also it is parallel to the ground level. So in this way this type of launch is called as horizontal launch. Now further we will study vertical launch. What is vertical launch? In vertical launch it could be of both sides. Suppose a person is standing on a cliff and throwing a ball to some angle. So some angle is formed like this, or some angle here theta. So this is the angle. He is throwing this. So after sometimes it will fall. It will go up and then it will fall. So this type of launch is called as vertical launch. And instead of throwing it upward, if the person throws it downward, then also it is vertical launch. I will explain you. So here the person is, this is parallel, so he is not throwing in this direction. Instead he is throwing downwards ball. He is throwing the ball downwards. Then this is also a vertical launch because angle is formed downward. So this type of in two conditions this vertical launch can happen. He is throwing upward, something is thrown upward, or something is thrown downward. So this type of things is called as vertical launch. From some height something is thrown downward, then it is vertical launch. And if something is thrown upward to some angle, then also it is called as vertical launch. Angle is formed. So this is the important criteria. Angle formed which is greater than 0, but here angle is not formed in case of horizontal launch. It is parallel. 0 angle is formed. So here I will give the example. The boy is throwing the ball. So boy is standing onto the cliff and he is throwing a ball like this, but he is throwing not upward. He is throwing the ball parallel to the so ball is moving parallel and it will fall down later on. So this line is parallel to this. So when it is parallel, this is forming like parallel lines. So this type of launch is horizontal launch. So for horizontal launch, we have understood that we have taken few equations and we have done questions. So these are the basic rules for horizontal launch. Like for a straight line launch which is parallel to x-axis, angle formed is 0. So that we have discussed. Normal straight line kinematical equations are used to find out displacement, velocity and time. Like s equals to ut plus half at square, v square equal to u square plus 2s, or v is equal to u plus at. These three equations are only used here. Considering the value of g as positive or negative, this we have to consider very nicely, and we have to remember the important point that if object is thrown away from the earth, then it is moving away from the earth, then we have to take g as negative. And if object is falling towards the earth, then, or if object is falling or thrown towards the earth and it is falling down, uh, initially it has been thrown towards the earth, then g is taken as positive because object is thrown towards the earth. Now we have to consider what happens to the vertical launch. If suppose some angle formed which is greater than 0, then what will happen to the acceleration and velocity? Here it is very important. We should understand that. So here velocity, horizontal direction velocity is constant. So what it means, like see, if something is thrown like this, a ball is thrown upward, so the ball will move like this and will come down here. So here you can see the velocity along the x direction, means along the line which is parallel to the ground. So this is ground. So these lines, this line parallel to the ground, this line. So velocity in this direction. This, 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 this will always be constant. Suppose the person is throwing the ball at 5 meters per second. Meters per second. So here also it will be, at this point also it will be 5 meters per second. At this point also it will be 5 meters per second. At this point also it will be 5 meters per second, which is parallel to the ground level. So all this, it will be 5 meters per second. So horizontal velocity remains constant. Okay. Now here vertical directions velocity y-axis changes with the g. So we will take this same example. The person is throwing the ball. So ball will move like this. So here we can see the velocity is changing here. Suppose velocity here with the initial velocity of 5 meters per second. That is being thrown. 5 meters per second along the y-axis it is being thrown. So this is the y-axis. So here at this point the velocity will be suppose 5 meters per second. Then later on it will become 4 meters per second. It will decrease 4 meters per second. Then here it will become 3 meters per second. Then here it will become 2 meters per second, and at the top it will become 0 meters per second in y direction, means upward, because upward it is not moving, it has become constant. Now it will fall down. 5 4 3 2 1, then again 0, then again here when it is falling down, then it will come, the arrow will come like this downwards, not upwards. So this you have to remember. So 0, then again it will become, from here then it will become 1 meters per second, 2 meters per second, then 3 meters per second, then 4 and 5 meters per second. Like that it will fall down. So it increases then decreases. First it goes on increasing, then comes to 0, then again start increasing. Okay, so this you remember, start increasing. First it goes on increasing, first it decreases, then it goes on decreasing, then from the top again when it becomes 0, then it again increases while coming downwards. So this is the rule which you have to remember for horizontal velocity. See, as we have discussed here, like this. So here it is launched like this. So you can see the velocity along this direction, which is parallel to the earth, is constant. So when the velocity is constant, like 5 meters per second it was, here also 5 meters per second at this point, here also it is 5 meters per second, here also it is 5 meters per second, here also it is 5 meters per second, and here also it is 5 meters per second. So everywhere it is 5 meters per second, which is parallel to the ground, means along the x-axis. So all the x component, x-axis, it is constant. So we can say here this, it is velocity is constant. So if velocity is constant, means there is no acceleration, because zero acceleration will be there, because rate of change of velocity is acceleration. Acceleration is defined as rate of change of velocity. Here velocity is not changing in x direction, so that's why there is no rate of change of velocity. No rate of change of velocity or along x direction, along x-axis or parallel to the ground. So there is no acceleration, means acceleration is 0. That's why acceleration along the x-axis is 0. And acceleration along the vertical y-axis depends on the g, gravitational force. Suppose a boy is throwing the ball. Now he is throwing, so it is going against the gravity because he is throwing upward. So initial velocity is like this, so it will go upward, so it is minus g. We have to consider this as minus g. So acceleration along the y-axis is minus g. But if a different case is there, suppose a boy is standing on a cliff and he is throwing the ball. So this is the cliff and he is throwing the ball here. So the ball will move like this upward direction, then it will fall. So it is moving again against the gravity here, so moving upward. So that will be a, because it is initially moving up, and here some angle is formed. So he has thrown this upward. So whenever he is throwing this upward, so some angle is formed. So when he is throwing against the gravity, so here also a equals to minus g. But in third case, suppose a boy is standing on a cliff. Okay. Instead of throwing it upward, he is just dropping the ball. So he is dropping the ball, so ball will fall like this. So he is throwing this towards the gravity, and the ball is falling towards the gravity automatically because he is dropping the ball. He is not throwing upward or downward. So here actually he is just dropping it. So it is moving towards the gravitational force. When it is moving towards the gravitational force, then you have to consider a as plus g. So this is very important. So this you should remember well. Now we have to derive few equations for vertical launch. Before doing few sums, so we have to derive the equations. So first thing we will derive is time of flight. So for this, suppose a projectile is launched like this. So some angle is formed, that is theta here. So this is y component and this is x component. So here, but we will consider only y component for time of flight, because till here we will first find out half of this time of flight. So it will move like this. So it is moving like this. So here it will become parallel. So here this component, so this direction is u sine theta, which is perpendicular we take as sine theta, and this direction which is parallel we take as u cos theta. So here also u sine theta, upward is u sine theta, and parallel to the ground is u cos theta. So in this way we will first find till here for y direction to find the time of flight, because time of flight means it is moving upward and then downward. So time is for this only, from upward to the downward. So if we find from here to here, this from here till here, then we will multiply with 2 and we will get the remaining also. So time of flight, for that derivation we will use few things. So we have to find from this direction to this direction, A to C, and here B is there. So for this first we will find only A to B, then multiply by 2, because from here to here what is the distance traveled is all equal to this only. So this A to B is equals to B to C. So first we will find for A to B to derive this equation. So initial velocity along the y direction is u sine theta, and acceleration along the y axis depends on g, and the ball is thrown upward against the gravity, so we will take it as minus g, and velocity along the y direction is considered as, so velocity along the y direction, that is final velocity, because when it will reach the ground the velocity will become 0, so we will take it as 0. If we want to find time. So we have three kinematical equation. V square equals to u square plus 2as, s equals to ut plus half gt square. So here time in s equals to ut plus half gt square, time is there, and v equals to u plus at also time is there. So we can use this equation v equals to u plus at to derive this. V equals to u plus at. So here you can see we will now substitute the values here. So velocity, final velocity equals to initial velocity plus acceleration into time. So all this now we will substitute the value. Vy, here it is 0 given, so we will write here 0. Uy, here it is given u sin theta, and acceleration is given by minus g, so plus minus g, and then into t. So now till here we have done. Now we will rearrange this. All this we will rearrange. So t, we can take this side. If we write like this, t equals to u sin theta upon g, because it is g na, so g will come down. So here g will come down, and it is coming in other direction, so it will become plus g. This when we are substituting the value, it will become. So as you can see here, so we can write like this also. So gt minus gt equals to minus u sin theta. Minus gt equals to minus u sin theta. So minus g equals to minus u sin theta. Okay, so we can write like this, t, or we can write this as, now this negative will go away, this negative will go away. Now here this we can take, here t we can take in this direction, and g we can bring it down. So t equals to u sin theta upon g. So this is the same thing what we have got here. So this is the time of flight till A to B. This is the time of flight till A to B, from A to B, from A to B. Now A to B is this one. Now from B to C is also equals to A to B only. So if we want to find A to C, flight of this time of flight from A to C, then we will just multiply this whole thing with 2. So here we can write like this, t equals to 2u sin theta upon g. So this we can write as capital T, because from A to C we are taking. Capital T equals to 2u sin theta upon g. Now second derivation we will do is for the maximum height or y max. So here you can see in the same projectile. So you can see in the same projectile here, we have to find this maximum height or y max, means along the y direction how much maximum height it has attained along the y direction. So this is y direction and this is the x direction. So this is how much, this is the maximum height which the ball has reached. So this we will write as y max or h. We will consider this as h. When we are deriving this, so we need s. We want to find this s value, which is equals to capital S. So we will find out maximum displacement. So we will use this formula, v square equals to u square plus 2as to derive this. So here we can take this from A to B direction. From A to B direction. At B it is at the maximum height, and at C it is again coming to the ground level. So this is the height which we want to find out. This B, point B. So we will write along the y direction, initial velocity along the y direction is u sine theta, and final velocity along the y direction is 0, because here it is becoming 0 now. Vy equals to 0. Vy equals to 0. Final velocity along the y direction is 0, and acceleration along the y direction is equals to minus g, because it is thrown against the gravity. So it is minus g. Now we will use this formula and substitute the value. V square equals to u square plus 2as. V square equals to u square plus 2as. So here v square means 0. This is the value. V square means this one. V along the y direction. So we can write 0 equals to u square means u sine theta. U sine theta plus 2g and s equals to h, this displacement. So yes, we can write like this as h, 2gh. So here h, so now we will bring this side, this one. So minus 2gh equals to u sine theta. So this is minus g. So here we can write here minus g. So this minus g, when it will come here this side, so it will become plus here. So this side it will become plus, minus g will become plus here, and u sine theta. So here in this way it is there. Now h equals to u sine theta upon 2g. So u square sine theta upon 2g. So here we have taken this as u square, so we will square this also and this also. So this also we will square it. So it will become h equals to u square sine square theta upon 2g. So this is y max. We can write maximum height along the y direction, y max. Also it is called as y max. So y max or h is equals to u square sine theta upon 2g. Now we want to find maximum range of the projectile. Means we have now found h direction, maximum displacement along the y direction. Now maximum displacement along the x direction we want to find out for this projectile. So here it was A, B and C, means total distance. This is the distance from A to C. Means this distance we want to find out from A to C. This is the distance we want to find out, how much it is there. So this is called as range also. So we will find out. We found for y direction here, that was h, capital H. Now we will find out range along the y direction. As we know very well, along the x direction it is considered as u cos theta, and in along the y direction it is considered, initial velocity is considered as u sine theta. So we will write all the values for x direction. Now we are finding out. So for x direction we know u x, initial velocity along the x direction is u cos theta, and acceleration along the x direction is 0 because there is no change in the velocity, and displacement along the x direction is, we have written it as range r. So time we will consider it as capital T. So now we will substitute the values of everything. So here s equals to ut plus half at square, half at square. Okay, so here we will now substitute the values here for this. S is equals to r, so we will write r equals to initial velocity u is equals to u cos theta, so we write u cos theta. Okay, so into time, we just derived previously. Time is u sin theta by g, 2u sin theta by g. Then acceleration along the x-axis is 0, so plus half into 0 to 0, so this whole thing will become 0. Okay. So now r equals to u cos theta 2u sin theta upon g. We can write this as uu, this u we will write here. These two u's we will write as u square r equals to u square cos theta sin theta by g, 2 cos theta or 2 sin theta cos theta upon g. So this is the formula. So 2 sin theta cos theta is also given as sin square theta, so we can write this range equals to u square sin 2 theta by g. So these two formulas are there. U square sin 2 theta, or range is given by this formula also, u square 2 sin theta cos theta by g. Now we will solve a question based on this vertical launch. So here this is one. So the sum is saying that in an indoor match, shuttlecock was hit with a shuttlecock racket from a height of 1.2 meters. So the height of this, from the height of 1.2 meters from the ground level, the height of the ceiling from the ground level is 12 meters. The velocity of the cock at the start was 10 meters per second, which makes an angle of 60 degrees from the horizontal. Find out the shuttlecock, whether the shuttlecock hit the ceiling or it did not hit the ceiling. So we will make a diagram for this, how it will look. So this person is here, shuttlecock. Here he is taking the racket and he is hitting this shuttlecock like this. So the height where this is there, the shuttlecock is being hit, this height, and this is the ground level. So this height is given as 1.2 meters from here to here, and ceiling, now here ceiling is there, ceiling we will make here, and this is the ground level. So this is ceiling, CE and ceiling. Now whether it will hit the ceiling or not, that is the question they have asked. And the height from the ground level to the ceiling is 12 meters. From here to here it is 12 meters. So this is the height, 12 meters. So whether it will hit the ceiling or not, that is the question. This shuttlecock will hit the ceiling or not. So it will move like this. So it will hit or not, that is the question. It may hit also, it may not hit also. So let's see with this, whatever the parameters they have given, whether it will hit or not. So we will solve this sum. So just now we have derived one equation for y max. So that formula we will apply here. So y max or height, maximum height along the y axis. So this is the maximum height which ball can reach along the y axis, means along the vertical direction. So it was u square sin square theta upon 2g. So this is the formula. So now we will use whatever the parameters are given. So we can write here initial velocity is 10 meters per second, and then angle theta, the angle formed, this is theta. So theta is equals to 60 degrees. So theta is 60 degrees, and gravitational G is 9.8 meters per second. 9.8 meters per second square. This is the acceleration due to gravity. So we will substitute this value and we will find the answer. So here y square, we can substitute 10 square. In place of u, we will substitute 10 square equals to 10 square. Then we can write sine square 60 upon 2g means 2 into 9.8. So here we can write this as 10 square and sine square theta it is, so we can write as a whole square theta, whole bracket we can write 10, then sine theta, sine 60 means, and whole bracket close, upon 2 into 9.8 we can write as 9 to 8 plus 19.6 means here we can write 19.6. So we will solve this whole thing. So here I am solving this, here I will take it. So here we can write 10 into sine 60 is 0.87 on my calculator. So here we can write 10 into 0.87 divided by 19.6. So, and this is whole square. So now I will solve this on my calculator and we will find out the value. So the answer is coming to 3.86 meters. 3.86 meters. Means 3.86 meters is the answer what the ball can reach here. So this is that. We can see this also from here, from the horizontal direction, x direction, and this ceiling. The real height is, this is the real height. So it is 12 meters. This minus this 1.2. So 12 minus 1.2. 12 minus 1.2, 10.8. So 10.8. 10.8 is the height from this horizontal to the ceiling, and the ball is reaching only 3.8 meters. 3.8 meters. So ball is reaching only around this 3.8. Shuttle is reaching till here only 3.8 meters. So 3.8 only it is reaching. So that means it will not touch the ceiling. If it is greater than 10.8, suppose the answer comes as 10.9 or 11, then it will hit the ceiling. But the answer is coming as lesser than 10.8. So 10.8. So our 3.8 is lesser. So 3.8 is lesser than 10.8. So it will not touch. So it will not touch the ceiling. So this is the answer for